Today we're doing section 5.2, Green Book. You can pretty much, there'll be one section in here that actually it won't be in the Green Book, it won't be in the new book. It will be actually just one little lesson that we will be doing, but for the most part we are in the Green Book for all of chapter 5 and all of chapter 6. Today we're doing a power to a power to a product, and power to a quotient. I'm going to remind you, a product is when you multiply two things together. Quotient is when you divide two things. Right? Okay, so power to a power rule. This is how I just describe it. I usually describe it how I see it. I call it the outside-inside rule. When you have an exponent inside the parentheses and an exponent outside the parentheses, we multiply them, as opposed to in this case, when I have like bases like x squared times x to the fourth, we add the exponents, right? But here we'd be multiplying when it's outside, inside. Notice here they're both inside. You guys with me? When they're both inside, it means we're going to multiply. When we multiply, we really add exponents. Does that make sense? That was yesterday's rule. Today, when you see the mixture of one inside the parentheses and one outside, inside, we are going to multiply. Here's why. If I have n to the second power, this really means n times n times n. And then if I square that twice, that means n times n times n times the same thing twice, right? N times n times n times n times n times n. Isn't that the same thing as n to the sixth power? Yes or no? So we can show our shortcut here is just when we multiply our exponents. N to the third power times the second power. Okay. When you're doing this today, I do want to see this. I want to see you write that out for right now. Okay. Especially the more complicated they get, the more likely you have to write it out. When it's something like this, I'd be okay if you just jump to n to the sixth. But as we get to the more complicated ones with lots of things going on, I'm going to want to see you write it out. Okay? All right. Can I move on? Are you guys good? Yes? All right. So let's use our power to the power. So in number 1, what are we doing? Number 1, what are we going to do? It equals, somebody help me through, go, Eitan.
Y to the 12.
Right, we're doing y to the third power times the fourth power, which equals y to the 12th power. Pause the recording and you do 2, 3, and 4. Making sure to always write the question and the answer. All right, number 2. Let's go with Max. What'd you get?
I got n to the 15th power.
Good. So we are, and when we're doing that, we're really showing 3 times 5, which is n to the 15th. Okay, next one, let's go Julia.
We got t to the 6th power.
Good. And number 4, let's go with Daisy.
K to the 14th power.
Good. Okay, pretty easy. Okay, now we're going to jump to product to a power. Okay, a product to a power is when you have two things multiplied and they're both to a power. That means that x is to the nth power and y is to the nth power. Everything inside is to the nth power. So on number 1, we're doing 3 is going to be, let's see how they do it. They're going to do 3 is to the second power and x is to the second power. And then we have to simplify the numeric portion, which is 9. I never want to see you give me an answer like this. When I ask you to simplify, I don't want the answer like that. Do you understand? Okay. So it's 9x squared. So I'd like you guys to put the recording on and work on the next 3. Remember, you're always writing the question and the answer. What do we get for 2y to the third? Number 2. Go, Brianne. What do I do?
So what I did was 2 to the 3rd power times y to the got 8y to the third
Perfect. Next one. Let's go, Jamie.
What I did is negative 5 squared times m squared, and I got positive 25m squared.
Perfect. Okay. Positive 25m squared. And Chloe?
So, first I did the 4, and I got 4 cubed times t cubed, and then I cubed it, and I got 64t cubed.
Perfect. Okay, questions? All right, so now they're getting a little bit more complicated, and this is where I really would like you to show me. So we are going to do, I'm going to do the first one, and then you guys can do the others. Negative 2 is to the 4th power. A squared times the 4th power. B to the 3rd times the 4th power. And C is right now written to the 1st power times the 4th power. So what does that simplify to? 2 to the negative 2, it's the whole negative 2. The negative is to the 4th power. Is that positive or negative?
Positive.
Positive. And 2 to the 4th power is what? 2 times 2 is? Times 2 is? Times 2 is? 16. A is to the 8th, B is to the 12th, and C is to the 4th. And there is my final answer. Okay, I'd like you to pause the recording and do number 2 and 3. So what do we do for number 2? Who wants to do this? Okay, Daisy?
So first, you would have negative 5 to the 2nd power.
Good.
Then x to, well, it would be x to the 1st power times the 2nd power, so x to the 2nd power.
Good.
Then y to the 20th power, because it'd be 10 times 2.
Uh-huh.
And then z to the 6th power, because we multiply the 3rd power times
3
the 2nd.
times 2. Okay, and what does it simplify to?
25, 25x to y.
X squared.
X squared times y to the 20th power times z to the 6th power.
Right. We don't even need to say. All we can say is 25 x squared y 20th z to the 6th. Good. Next one. Don't all volunteer at once. Okay, Brianne? I think that was like a volunteer. She did this. Okay.
So I got
No, tell me what to do. No.
so negative 8
Mm-hmm. Times.
times n to 3rd times 2nd power,
Good.
and then p times to 4 times 2 power,
Times the 2nd power.
and t to 0 to the 2nd power.
Times the 0 power. Okay, and what does it simplify to?
And I got negative 8 n to the 6, p to the 8.
And t to the 0. But what does t to the 0 equal?
1.
It always equals 1. So do I need to write negative 8 n to the 6 p to the 8th times 1? No, we don't need to write it. So she was right in the way she said negative 8 n to the 6th p to the 8th. I don't need to write times 1. Okay, questions? Okay, so do you understand t to the 0 is always going to equal 1? All right. Questions? Moving on. Oh, we're almost out of time, so I'm going to keep going and we'll come back. Can I skip these? You understanding what to do, right? There's actually some more good ones right here, but I'm going to first... Oh, let's do one of these. Yeah, let's do this first. Okay. So now this is really where you kind of, we're going to take one piece at a time. So what would this one be if I simplify it? Just pretend the rest of it isn't there. We're just really kind of dealing with this. Okay, go.
That'd be 3 squared,
3 squared.
x squared times 2, y cubed times 2.
Good. And then I'm going to simplify it further.
It'll be,
Times 2. 3 squared, sorry.
it'll be 6.
No. 3 squared means 3 times 3.
Oh, 3 times 3 is 9, 27.
How are you getting?
Because you wrote 3.
I did not. I went over it and I put a 2.
Oh, so it's 9.
Yeah.
X to the power 4
X to the 4th,
and y to the 6th.
y to the 6th, okay? Then I've got to do the next one. What does that become?
Negative 4 squared, x squared, y squared times 2. So it'll be 16 x squared and y to the power 4.
Okay, now what do you think we do? We use yesterday's rules. Gonna go for it?
You have to combine the
Combining implies adding, but we do rearrange and use we use commutative, and we multiply like base with like base, coefficient with coefficient. So 9 times 16 is 144. You understand? And I'm going to do an extra step. I'm going to do 9 times 16, x to the 4th times x squared times y to the 6th times y to the 4th. Now you can notice there's no more outside inside. So now what do? 9 times 16 is 144. What is x going to be to what power?
to the 6th.
6th power. We add them. And y is to the 10th. Is everybody clear on that? So here, we use yesterday's rule. When it's a common base, we really add the exponents. A common base where they're being multiplied, we add the exponents. When we have outside, inside, we multiply them. Try the next one, go. Pause the recording and go on to number 2. All right, let's check number 2. So what do we get for the first one? Who wants to do this one? Okay, Max.
Well, I got, for the first one, I got 4, 8 to the 6th.
Wait. 8 to the 6th?
No, I got, so I did 2 squared.
2 squared, thank you.
8
A to the 6th.
B to the 10th. And
Good,
C squared.
good. And then the next one?
I got negative 2 to the 3rd. A
Good.
to the 3rd. And B to the 12th.
Good. And now, what is, let's simplify. 2 squared is what?
4.
4a to the 6th, b to the 10th, c squared. And what? And negative 2 to the 3rd is?
Negative 8.
Okay, and what did you finish with?
Negative 32, A to the 9, B to the 22nd, and C squared.
Perfect. Okay, you guys got it? All right, so there's a little bit more that you're not really going to cover. Well, I'll come back to it. All right, so now we're going to do product of a power of a quotient. So if there's an exponent and you have anything inside is to that power, right? So in this case, 2 would be squared. I would square 2, I would square x, and I square 5. And you can't leave the numbers with exponents. If I say express using exponents, I mean the variables using exponents. The numbers you wouldn't. So that would be 4x squared over 25. You want to pause the recording and you guys try number 2. Go. All right, so we're doing, who haven't I called on? Mike?
So I did 5 squared,
5 squared.
and then 2 times 2, like,
And B,
and 4 times 2,
4.
3 squared.
Good, and it simplifies to, we're recording.
25 A to the 4th power, and B to the 8th power over 9.
Over 9, good. Okay, questions? All right, let's do some more practice. Okay, pause the recording, try the next few. All right, now check your work. So the first one would be y to the 20th over 3 to the 5th would be 243. Number 2 would be 8, a is to the 21st, 5 to the 3rd is 125. You guys understand? 2 squared would be 4, 3 squared would be 9, and a would be to the what power? 8th, and b would be to the 4th. You guys get the idea? I want to jump to another slide really quick. Oops. So I'm going to show you that last one was 16 x to the 4th, y to the 2nd, 4 over 49 a squared. All right. Here's using power to a power, and let's just first look at it. So the first one I'm going to do the power to the power. So what would that simplify to? 9 x to the 4th and times 5x minus 2, well, minus what? Let's do our power to power.
Minus 6.
2 to the 4th would be 16. X to the 4th, x, right. All right, next step we're going to do is use yesterday's work. Okay, so this was power to a power. Okay, the next thing we're going to do is our rule of, right? Let's say they're going to do it. The next thing we're going to do is we multiply. What would simplify just this side? What would we do? What would this simplify to? Go, Jamie.
45x to the 5th power
Good. Minus.
minus 16x to the 5th power.
Okay, so now we're using our rule of just exponents multiplying common bases. Got it? Yesterday's rule. And now what can I do? Yes.
40, I think you can subtract x to the 5th minus x to the 5th.
Right?
And then 45 minus 16.
No.
Okay.
It's one term, and these are like terms. It's like if I have 5 x's and I subtract 2 x's,
yeah.
I end up with 3 x's. I end up with 3 x's, okay? So if they are like terms, the exponents do not erase, we don't subtract them.
Okay.
It's like I have 45x to the 5th, and I take 16x to the 5th away. How many x to the 5th do we have left?
Oh.
Okay, and so when we subtract, 45 minus 50 is 30. So let's go 29x to the 5th. And that is the rule of like terms, combining like terms. Do you understand how to put all these together? Try number 1. Go. Pause the recording. Try number 1. Okay, let's check our work. So the first one should simplify. This becomes 9a to the 6th, b squared, c to the 6th. And the other one becomes 4a to the 4th, b squared. And then that simplifies to, what'd you get? 36?
No, I have a question.
Okay, 36, a to the 10th, b to the 4th, and c to the 6th. Minus, over here I'm getting a to the 3rd, b to the 3rd, c to the 6th, right? Times 5a to the 5th, b to the 1st. So that simplifies to 5. I have a to the 8th. Oh. A to the 8th, yes. Oh, this, I see, because it was wrong. Right here, right?
Yeah, that's what I was thinking.
Okay, thank you, sorry. So it's a, this should be to the 8th. Okay, a to the 8th, b is to the 4th, and c is to the 6th. Are these like terms?
Yes.
How do we tell if they're like terms?
They're both,
The variables and their exponents have to be exactly the same. So it's a to the 8th, b to the 4th, c to the 6th, a to the 8th, b to the 4th, c to the 6th. So this becomes 31, a to the 8th, b to the 4th, c to the 6th. And we are done.